Hi everyone, welcome back to my channel. Let's see what I've learned over this week. Today's topics are going to be 1. Publication, 2. Safe publication, 3. Escape and unsafe publication, 4. Safe practices that are to be followed in constructor. Now let's have a look at the class holder. Holder class has a single field X which has a synchronized getter which returns X. I have a static holder object variable which is initialized in the init method with X value being 42. Now this static holder H is being accessed by many threads which access the X value from H.get, that is the synchronized get. Now it is expected that as the getter is synchronized, the access is thread safe and each thread should get X as 42. But this is not the case. While some threads are getting the value of X as 42, other threads are getting it as 0. Why is this the case? This is because it was assumed that thread safety began at the usage, that is with this synchronized getter method, but that was not the case. Bugs were happening even before this, that is when the new holder object was being exposed to other threads via this static holder H variable. So in this assignment step only, many concurrency bugs were happening, resulting into an inconsistent object from the start itself. So even if I had synchronized getter for this object, it is not useful because the object itself is not correct in the first place. So before threads can safely use an object with synchronized getters, they should see a correctly constructed object, which is not happening over here. So that brings us to the definition of publication. An object is published when its reference becomes accessible to other threads. In this case, H was assigned a new holder object in this stage, and when it was assigned, the reference value became visible to other threads because H was static. So to summarize our learning, an object becomes thread safe when its publication as well as usage is made thread safe. If either of them remains not thread safe, the code becomes buggy. Now an important distinction. Publication doesn't mean initialization or creation. It means exposure. Now in our case, new holder object is getting assigned to H, because of which it is getting exposed to other threads. That is why we can say new holder object is getting published in this place. Now let's move on to safe publication. Publication with a happens before guarantee between construction rights and the first read by other thread. Now let's see what is happens before guarantee first, and then we'll look at these both. Happens before is a promise made by Java memory model. That is, if A happens before B, all writes that are done by A are visible to B, and Java is not allowed to reorder my operations if I have a happens before relation between them. That is, it cannot make B occur before A if I have A happens before B relation in between them. So it is a visibility plus ordering guarantee that is given by Java memory model. What happens if there is no happens before relation? Then Java is allowed to cache values, reorder instructions, show stale data, and expose partially constructed objects. Now let's see this example. Here I am initializing X and Y to 0, so the default values are 0. Thread 1 comes and assigns 1 and 2 to them. Thread 2 is printing the value of X and Y later. Here are all the combinations that thread 2 can print, and they all are legal. They are legal because there is no happens before relation in these operations. So JVM can reorder them and execute them. Now let's see what happens after I add a happens before relation. I am making Y as volatile and printing and assigning it after X. This is done in thread 1. Now in thread 2, I am doing Y if Y is equal to 1, print X. Here X is guaranteed to have 1 as its value. Because volatile is providing the happens before guarantee. Now if you all haven't seen my previous video for volatile, you won't really get this example. So you all can pause this over here, watch that video and come back again over here. So how to get happens before guarantee? First is synchronization. Unlock of M happens before lock of M. This means that all the writes that are executed by a thread before leaving a synchronized block need to be visible to other thread that enters the synchronized block after it. So the currently executing thread must release the lock before my thread can acquire the same lock. So that's what happens before in synchronization means. Second is volatile. So all the writes that are done before writing a volatile variable should be visible after reading that volatile variable. That's what happens before guarantee of volatile variable mean. Third is thread life cycle. Here thread.start happens before actions in a new thread. So the new thread cannot execute until and unless I call thread.start. That is a happens before guarantee between it. Now second is actions in a thread happen before thread.join. If I have called thread.join, the actions of the thread on which I have called this are guaranteed to be performed first before thread.join. So this is the happens before guarantee in thread's life cycle, and these actions cannot be reordered. Fourth is final fields. So properly constructed objects guarantee visibility of final fields without explicit synchronization. So we'll look more into this in our next video. So to summarize happens before, we can achieve happens before guarantee by synchronization, volatile variable, thread life cycle and final fields. Now let's look at this line again. Safe publication. Publication with a happens before guarantee between construction writes and the first read by other thread. Now if these two actions are reordered, that means construction has not fully completed and my variable or the object is read by other thread already. That can lead to concurrency bugs and inconsistent and unpredictable behavior of that object. Now that we have covered publication and safe publication, let's look at the examples. To summarize it again, publication means exposure and safe publication means having a happens before guarantee between creation and exposure. Now let's look at the first example. Publication via plain shared memory, that is by using public static. Let's look at the unsafe version first. Here I have a static variable foo which I am initializing in the init method. Now this is the same example which we saw first. Here what can happen is that foo being static can be accessed by multiple threads at the same time. So there can be a case that one thread might be in the process of initializing foo while the other threads can start using foo at the same time. So the other threads can see partially constructed object which is in the process of initialization and hence can lead to unpredictable behavior. Now let's see the safe version. Here I am adding a happens before edge by introducing volatile in the code. Rest of the code remains the same. Let's look at the two rules of volatile. First, all the writes that are done before writing a volatile variable are guaranteed to be completed before writing the volatile variable. That is, the order is guaranteed. There is no reordering. Second, all the writes that are made before the writing volatile variable are guaranteed to be visible after reading that volatile variable. Now, how do these help in this situation? Let's see. Here, foo, which is volatile, is getting assigned with a newly constructed object. So the construction needs to happen first and then the assignment needs to happen to the volatile variable. So the order here is first construction and then assignment. Because foo is volatile, this order is preserved. That is, the assignment won't get reordered with construction. That is why all the other threads will always see a newly constructed, completely constructed object, and no partial stages can be made visible because foo is volatile. Let's look at the order of execution for the safe version. First, I'll allocate object. So memory is getting allocated for the object. That is the first step. Second, the constructor is completed fully. And third, then the write to the reference is done. Okay, so this is when I use a volatile variable, and that is why I always see a fully constructed object. Now let's see the stages in unsafe version. First, memory is allocated. Second, the write to the reference is made. And third, constructor is completed. So here reordering of the steps is taking place, and that's why the object is getting visible early in its partial stages. So volatile guarantees safe publication, but that doesn't mean the object remains thread safe in its later stages. Also, holder.x++ is still unsafe because volatile doesn't provide locking. This is a compound operation and this can lead to race conditions. Other safe version includes the use of synchronized lock. Here also other threads will see a completely constructed object because synchronized also provides a happens before guarantee. Now the second method of publication is method return. Their code is very simple. Create method is returning new foo object. Let's look at the unsafe and safe version. The unsafe version will be that the caller thread which is calling create doesn't use synchronized while calling create. For example, foo_f is equal to factory.create. Supposedly, if these two are running from different threads, reordering or overlapping can cause unpredictable outputs. So this is an unsafe version. In a safe version, I use a happens before relationship. I either return from a synchronized block or I make the caller call from a synchronized block. Second, I can hand off the object to a blocking queue, which then the other thread uses and gets the object from there. Third, I can return from a thread started via thread.start. Now what does this mean? Let's look at an example for this. Here I have a class task. In task I have a foo variable which I am initializing in the run method. Later I am making a task object which I am passing to thread and then calling thread.start and thread.join. Later I am fetching the foo object from the task variable. Now at this stage I am guaranteed to get a complete object from the task object. Why? Because t.start and t.join are providing me with a happens before edge. That is, because of t.join, this code is guaranteed to be completed first, and because of t.start, I get a happens before edge that these two lines will be executed before a new thread is started. So the foo object returned over here is going to be complete because I have a happens before edge in my code that is provided by the thread lifecycle. Now the second type of publication in this section is passing to an alien method. An alien method is the one whose specifications are not clear, or if I'm passing my object to an overridable method, methods that are protected or that are not private or final. So it is unsafe because you don't know what the code will do to the object. It can publish the object, it can retain the object and use it later. So it is better to be safe than sorry. So that was it for this. Now third type of publication is publishing via collection. I'm adding the new foo object to the list. It is unsafe if the list is not thread safe. It is safe if it is a thread safe collection. Thread safe collection have internal synchronization that provides you with the happens before guarantee. Fourth is publishing via callbacks and listeners. So this line register new foo object is also publishing the new foo object. It is considered unsafe if register uses the objects without a happens before edge, and it is safe if the register publishes the new object via synchronization. So it depends. Publishing an object also publishes its non-private fields. So if an object is reachable via some chain of calls from your published object, then that object also becomes published. So that's why we need to be careful when we are publishing an object, and that's when encapsulation helps. So if some fields are not required to be public, we should always make them private. That will help us with thread safety. We saw what is publication, safe publication and unsafe publication. We also saw what is a happens before edge. Now let's see what's an escape. An object becomes reachable by another thread before the programmer intended it to. So escape is loss of control. So you didn't want to publish that object, but it got published by mistake. That is what is called an escape. So unsafe publication is when you want to publish that object, but you didn't use a happens before edge while publishing the object. And escape is when you didn't want to publish the object and it got published by mistake. Now let's look at some common escape patterns. First is this escape during construction. Here I am registering this instance in the constructor itself. At this point the construction is not finished. That means if there are any subclasses of foo, their constructors might not have been called at this point. If there are some invariants in this class, they might have not been established at this point. And there can be a case like if after registration immediately some thread can call the methods of foo class, and at this stage it can call methods on a partially constructed object, which is not correct. So we can say that this object has escaped its scope and it was not intended by the programmer for this to escape at this point. Now these next set of examples which show us this escape in construction includes the usage of inner class and lambda expressions. So why inner class and lambda expressions? Because they contain a hidden reference of the enclosing object. So let's see them one by one. In the first example, I am creating a new thread in foo's constructor and using lambda expression to pass runnable to it. In this runnable, I am calling do something method of the enclosing classes object, and here I am also starting the thread in the constructor itself. So now this thread has a partially constructed enclosing object, and on that object I am calling do something method, which is not correct. So my enclosing object has escaped and has been published because of a inner class. In the second example, I have a runnable R as a field in the foo class. I am initializing this R in the constructor with the help of an inner class which calls do something method of class foo, that is the enclosing class. Now the problem is, while initializing, if some other thread comes and uses this R to run this runnable, it can call the do something method on a partially constructed foo object, which means I have let this foo object escape before it was properly constructed, and this is the second example. Another example is where I am passing the runnable inner class to an executor and calling its execute method in the constructor itself. Here also my this has been escaped and the do something method is being called on a partially constructed object. In the fourth example, I am registering a new listener in the constructor itself by using an inner class. Here, I also have a line which says x is equal to 42, x being a field variable of the foo class. Now it so happens that a thread can call my new listener immediately after I register it. At this point, the object is not fully constructed. The enclosing object is not fully constructed and its method do something is being called on a partially constructed object. Do something is printing the value of x, which has not necessarily been initialized or visible at this point. So X can print 0 for that thread, which is a problem. So all these examples show us how this can escape with the use of inner class in a constructor. So to summarize the behavior of all the 4 examples, we can say an object is in predictable and consistent state only when constructor finishes and returns. Publishing an object within its constructor can give incomplete object with unpredictable behavior even if it is the last line in the constructor. Because you can't say that at that point whether the subclasses have been completely initialized or not, or whether the invariants are completely established or not. So it is better to let the constructor finish and then do the publishing. Let's list down safe practices inside constructor. First, only initialize fields in it. Second, initialize final fields completely. Third, call only private methods that don't leak this. Fourth, create inner class only if they don't let this escape. Now, as we have seen, inner classes have hidden reference to the enclosing this instant. But if we don't call any methods of the enclosing class, this won't be leaked. But you need to add proper comments while using inner class in the constructor, because in future enhancement there can be a possibility that a certain div can call the methods and let this escape. Fifth, publication after construction is complete and constructor call returns. For example, I am initializing the foo object over here, and then I am registering the foo object, and then I am starting a thread using foo object. So this is the correct way. You shouldn't do this inside a constructor. So for that, create a private constructor and create a public static factory method where all this happens after construction returns. Sixth, create threads but don't start them. Again, you require proper documentation in that code so that future enhancement don't make this mistake. Important note, never rely on synchronization inside constructor to fix escape. Here in foo's constructor, I am using synchronized lock to register this instance. Now, by using lock, I am fixing the visibility issue for this. That means other threads, if they use the same lock, they will the value of this instance will be clearly visible to them. But that won't mean that they will see a complete object at this point. They can see a partially complete object at this point even if the visibility issue is fixed. So, synchronization may fix visibility here, but it does not fix object lifecycle correctness. Seventh, never call overridable methods, that is protected methods from constructor. Subclass fields may not have been initialized yet, so that can lead to breakage. That was all for this instance escape. Now let's look at the second example, allowing mutable state to escape. Here in the box class, I have a private list of string, and this private list is made accessible by a public getter. Now, if I have not intended for it to be accessible to other threads, this getter is making it accessible. So confinement is broken. So that was it for this week. We have covered publication, safe publication, unsafe publication, escape, safe practices in constructor, and what happens before relationship in this video. Let's meet again the next week, hopefully, and explore concurrency further. Till then, study and have a great time.